Good morning once again for the students of Building Design 1. Our topic for today is all about the materials in concrete. First, what is concrete? So, concrete is a mixture of cement, paste, fine, and coarse aggregates. The cement paste consists of cement and water, which bind the fine and coarse aggregates. When the mixture has sufficiently set, it takes on the characteristics of hard stone. Then, for the fine aggregate, should consist of natural sand or of inert materials within similar characteristics, having clean, hard, and durable grains free from organic matters or loam. Then for the coarse aggregates, should consist of crushed rocks of durable and strong qualities or clean and hard gravel. The size of the coarse aggregates varies from 20 mm to 38 mm in diameter. Then next, so one thing also is the water to be used for mixing concrete should be clean and free from injurious amount of oil, acid, alkalis, salt, and other organic matters. Then next, for the Portland and pozzolan cements. So two widely used cement blends employed in the preparation of concrete in general construction are Portland cement and pozzolan cement. So we will discuss first the Portland cement. So Portland cement has been defined as a hydraulic cement produced by pulverizing clinker consisting essentially of hydraulic calcium silicates and usually containing calcium sulfate as an underground addition. So under Portland cement, so we have 5 types of Portland cement. So for the type 1, so this is the most widely used Portland cement for buildings and is also the least costly. So it reaches its full strength after 28 days. So we have curing days for the concrete. So 7 days, 14 days, 21 days, and 28 days. Wherein in 28 days, so it reaches the full strength of the concrete. Then next for the type 2. So type 2, a moderate heat Portland cement used for large concrete pours where less heat is desired during the concrete set. Then for type 3, this is a highly early strength Portland cement which gives more strength before 28 days than type 1. So it means before 28 days, so the cement has already reached its final strength. Then for type 4, so low heat Portland cement like type 2 that releases less heat during the concrete set. And last is the type 5, a sulfate resisting Portland cement. So this is the most expensive cement. So, and next for the pozzolan cement. So under pozzolan cement, so we have 2 types. So pozzolan cement has been defined as a hydraulic cement consisting of a mixture of Portland cement and definite amounts of natural and artificial pozzolanic materials like volcanic tuff, shales, clay, fly ash, blast furnace slag, burnt clay, and etc. So for the first type of pozzolan cement is the type P. Pozzolan cement used in general construction where high initial strength of the concrete before 28 days is not required. However, after 28 days, it meets the compressive strength to which it is designated. Then the next type of pozzolan cement is the type 1P. So this type of pozzolan cement is an early strength cement and is required for more critical concrete works. So the magnificent structures among the wonders of the world today, which were constructed out of pozzolan cement thousands of years ago by the Romans, are cited as proofs of the toughness and durability of pozzolan cement. It is also said that new technologies are introduced to improve the cementing qualities of the pozzolan cement. However, one who specifies pozzolan cement should be knowledgeable about its technical properties so as to choose the correct type that is suitable for each concreting job. So next, so what are the admixtures in concrete? And first we define the admixtures. So admixtures may be added during the preparation of the concrete. So these are substances mixed in concrete to impart certain desired qualities. So among such qualities are to improve the workability of the concrete, to increase its waterproof characteristic, to harden its surface, to accelerate its time setting, and etc. So that's all for the admixtures in concrete. So what are the examples of the admixtures? So it may be a starch, it may be a liquid, it may be a ash, and so on and so forth. It depends on the engineer's discretion on what admixtures he would provide or he would add in the concrete mixture. Then next is for the proportions of the concrete. Varying the amount of cement, fine and coarse aggregates, and water in a given volume of concrete results in different strengths of the mixture. The quality of the concrete to be used in a given project is specified in different ways, such as by its water-cement ratio, weight of a given volume, compressive strength after 28 days, and the fixed proportion of cement, fine and coarse aggregates by volume contained in the concrete mixture. So under the last method, the concrete mixture are identified by classes in which class contains a given proportion of cement, fine and coarse aggregate by volumes as shown below. So under the proportions of concrete, we have 1, 2, 3, 4, 5. We have 5 classes of concrete. So first is the class AA. Actually, we have also a another class of concrete which is not included here. So first is the class AA. So the cement, sand, gravel by volume proportioning is 1:1:1 1/2:3. So the probable strength after 28 days is 4,000 psi. So it is in English. So let's try to convert it in metric. So 4,000 psi is equivalent also to 27.58 megapascal. So then next, so for the class A, so this is the most commonly widely used in the construction projects for the residential structures. So it is 1:2:4, which is 3,000 psi or equivalent to 20.6 megapascal. Then class B, the proportioning is 1:2.5:5. So the probable strength is around 2,000 psi, which is 13.79 megapascal. And the last two is the class C and the class D, which is 1:3:6 with a probable strength of 1,000 psi equivalent to 6.7 megapascal. And last, class D, 1:3.5:7 less than 500 psi. So 500 psi is equivalent to 3.45 megapascal. Excuse me. Then next, for the proportioning of the concrete, for example, if the concrete mix to be used for a certain building part is indicated on the drawing or in the specifications as class A, it means that for every bag of cement used in the mixture, a corresponding 2 parts of fine aggregates and 4-part coarse aggregates should also be added. So it means that if we need a bag of cement in the concrete mixture, we need also 2 parts of sand, which is 1:2, and 4 parts of gravel, plus enough clean water to make the mixture into a pliable paste. So usually the water cement ratio is around 0.4 or around 0.5, but it depends on the engineer also. It is his discretion, his or her discretion. So that's an example for the proportions of concrete. Excuse me. So what are the procedures in estimating sand and gravel in concrete? So method number 1. So we are already in the procedures in estimating the materials, or estimating cement, sand, and gravel in concrete. So method number 1, procedures using formulas based on the volume and class of concrete mixture to be used. So first is compute the volume of the concrete member in cubic meters based from the plans and detailed drawings of the project. So if necessary, refer to the formulas for computing the volume of various solids which may be assumed by concrete members in the construction. Then next, add to the above computed volume of concrete the allowance for wastage as discussed earlier. So we will need a wastage as discussed earlier to get the estimated total concrete volume. Then next, ascertain the class or concrete mixture used for each concrete part being estimated. This information can be found in the project specification or indicated in the working drawings or the plans. So on what type of what concrete strength we should use in the concrete mixture. Then next, substituting the estimated total concrete volume for C over V under the appropriate class of concrete shown below. Multiply it by the factors indicated to get the estimated quantities of cement, fine, and coarse aggregates required. So here is the multiplying factors. So this is the one that we will use in determining the total volume of the cement, or the number of bags of the cement, then number of cubic meters for sand, and number of cubic meters for the gravel. So how we will use this multiplying factor? So example, we have a class A 1:2:4 concrete mix. So after determining the total concrete volume, so we will multiply it by 7.85. So this is a factor for 1:2:4 concrete mix. So after multiplying it, so we can determine the number of bags for cement, as well as for the number of cubic meters per sand. So as you can see, 0.42. So we will multiply it by 0.42. So we can determine the total volume for the sand, and thus for the gravel. So we can also determine by multiplying the factor to the total concrete volume. So we can determine the number of cubic meters for the gravel. That's all for materials in concrete and the procedures in estimating cement, sand, and gravel in concrete.